Hello students, so welcome in today video lecture. So in this video lecture we are going to discuss the numerical solution of linear system of equation by iterative method. So guys, there are two iterative method in our syllabus, Gauss Jacobi method and Gauss Seidel method. So in this video lecture we are going to discuss the numerical solution of linear system of equation by Gauss Jacobi method. So guys, suppose that linear system of equation is given like this, means a11x plus a12y plus a13z equals to b1 and a21x plus a22y plus a23z equals to b2 and a31x plus a32y plus a33z equals to b3. This is our system of equation, means here is a three equation and three unknown. So we have to find the numerical solution of this system of equation by iterative method. So guys, let us discuss the first, what is a iteration process to find the solution of system of equation. Okay, so guys, here I have just given the brief about the iterative method ki how it will be work. So in iterative method we start from the initial guess solution. Initial guess solution, you can say that the initial approximation or the initial solution of any system of equation. Suppose that if you consider this system of equation, so here is a three unknown x, y, z. It means we have to calculate the value of x, y and z. So when we find the value of x, y, z, so we have to assume the initial approximation. So most of the time initial approximation are given in the question, and suppose that if it is not given, maybe here is a vector, we consider our vector is x, y, z. So x 0, y 0 and z 0, 0, 0, 0, or you can also take 1, 0, 0, 1, 1, 1, depends on you, or sometimes maybe it is given in the question. So if it is given in the question, so if because it is given in the question, so it is our the initial approximation, and initial approximation is very poor. Okay, and very poor means it is not our required solution. Okay, so means then we have to go the next step to compute the better approximation. Okay, and we have to continue this process till the required result is obtained. Okay, so guys, just I have given it the brief how it will be work. Means first we consider it is initial approximation, so it is very poor. Then we have to calculate the second iteration for better and better approximate solution. Means suppose that if we calculating x1, x2 up to xn, this denote the iteration procedure. Okay, it is the first iteration value, it is the second, it is up to the xm iteration, unknown solution of the problem. Okay, and guys, we have also given a graphical representation for the solution of any system of equations. So guys, in the example I have written three linear equation and three unknown, but here I have taken only the two axes x and y. So just guys, if you remember in the 9th or 10th class you have studied this type of the equation, the solution of this type of the equation. Suppose that if I at here a11x plus a12y equals to b1, means a21x plus a22y equals to b2. So when you finding the exact solution of this system of equation, so suppose that it is your the x-axis and y-axis, it is your x-axis and y-axis, and when you suppose that it is your the equation first and it is your equation second. So suppose that if we assume this is the line of first equation, okay, and it is a line of our second equation. So this line intersecting here, so it is our the solution of this equation. So similarly guys, so in this it is the direct method, but in this lecture we are going to discuss the iterative method, means indirect method. So indirect method we are not able to get directly this point, intersect point. Okay, so in this question, in this method we have to use the initial approximation. So suppose that if we take in here x equals to any particular value, means if we assume for the initial approximation x equals to 0.6 and y equals to, or x equals to 0.6 or y equals to 0.4, or you can say that it is over the y and it is over the x. So now we have to again the iteration. So suppose that here we assume first value y equals to this and this is x equals to this, and then we have to continue this process. So after the some iteration we goes here, so it is our the solution. Okay, it is our the solution of our system of equation. So it is for the two dimensions, but it will take with the three dimension. So we can take here the x, y and z, you. So you can take here, suppose that here to here like this. When you go, so our system is converge here, so it is the required solution. But for getting this solution, there is a one condition, and that condition is known as a sufficient condition. Sufficient condition means it is not necessary that condition will always true, but if that condition will be true, then 100% we can say that our solution will converge. Converge means we are getting the our required solution means here. Okay. So guys, here I have written the sufficient condition. What is a sufficient condition for convergence of the solution? So sufficient condition for the convergence is that the system of equation is diagonally dominant. It is a, I think, new word for you. Diagonally dominant means that is a coefficient of a matrix A is diagonally dominant. In mathematically I have written this one. But guys, if you look at the previous, I have written here what is your system of equation. So I think you have already familiar or the what is a coefficient matrix, but I am again writing here it is the system of equation, this one. So first we have to write in this form, means ax equals to b. Ax equals to b means where a equals to a is a coefficient matrix, you can write the coefficient of these equations. So it will become a11, a12, a13 and a21, a22, a23, a31, a32, a33, and here is a x equals to, you can say, is a variable x, y and z, and b equals to b1, b2 and b3. This is your the coefficient matrix, and it is your the vector column matrix, and it is also a column matrix for the constant. Okay, right hand side of the value of this system of equation. So guys, here we have to check for diagonally dominant condition, means when we write this system of equation in a matrix form, so this diagonal element means a11, a12, a11, a22 and a33. So means for the first row we have to check here ki absolute value. Okay, maybe it had the negative sign, means absolute value mod of a11 is greater than or equals to sum of the this value a12 plus a13, means we have to write here mod of a12 plus mod of a13, and same condition will also satisfy the second. So in this question our diagonal element a22, so in this row we have to check here ki a22 is greater than or equals to a21 plus a23, and here a33 is greater than or equals to a31 plus a32. So if any system of equation will satisfy this condition, then we can say that ki our solution of the system of equation will converge 100%. But you have to also remember it is a sufficient condition, not a necessary condition. Sometimes maybe this condition will not satisfy, but our solution will converge. Our solution will converge. Okay, so guys, if it is satisfy the diagonally dominant condition, means if the coefficient of x is greater than or equals to sum of the coefficient of y and z, then we have to find the value of x from first equation. Means for the calculating the value of x, you can write x equals to a1 by a11 into b1 minus a12y minus a13z. Okay, and similarly for the y, if the coefficient of y means a22 is greater than or equals to sum of the coefficient of x plus coefficient of z, then we can write y equals to 1 by a22 b2 minus a21x minus a23z, and for the third we can write z equals to a33 equals to b3 minus a31x minus a32y. Okay, so from this equation we can calculate the value of x, y and z. Okay guys, and suppose that sometimes maybe these system of equation are not satisfy the diagonally dominant condition. Okay, and when we rearrange the equation, then it will be satisfied. So guys, if these are not satisfy the diagonally dominant condition, so then we have to try to rearrange the system of equation. Means how to rearrange, guys? Suppose that if you write like this, it is or the 3x plus 2y plus z equals to 5, like this. And here when you write, you suppose that 3x plus 7y plus 15z equals to 9, and in this question you write 2x plus 25y plus 20z equals to 11. So guys, if you look at here, so in this question, in this equation, coefficient of x are greater than equals to sum of the coefficient of y and z, but in this equation coefficient of z is greater than equals to coefficient of x and y. So guys, here we have to rearrange, means we have to write this equation in here and this equation here. Just we have to rearrange the equation, then we have to follow the same procedure. Okay, and after this we have to write the iterative equation. So for the iterative equation, we will simply we can write here x n plus 1, and here is a y n, and here is a z n, and for this n y n plus 1, and here is a x n and z n, and here is a z n plus 1, and here is a x n and y n. So it is the iterative equation. Okay, so guys, then for the first iteration you can put here n equals to 0, and for the second iteration you can put here n equals to 1. For the third equation you can put here n equals to 2, like. And this process is repeated till the difference between two conjugative approximation, or you can say the two successive approximation, is negligible, means nearly equal. Okay guys, so it is our procedure to find the numerical solution of any system of equation by using the Gauss Jacobi method. Guys, let us discuss the one example. Okay students, so look at this question. So solve the following system of equation by Gauss Jacobi method. And here initial approximation is given 0 0 0, means x equals to 0, y equals to 0, z equals to 0, and it is our system of equation. So guys, first we have to check this system of equation is diagonally dominant or not. So guys, here I have written in the first equation coefficient of x is a 20 and coefficient of y 1 and z is a -2. So simply we have put it 20 is greater than coefficient of y plus coefficient of z, and similarly it also satisfies the second equation, and this is for the second and it is for the third. So here you can say that the given system of equation is diagonally dominant, then system of the solution of this system of equation is convergent or converges. Okay, here it is the mathematical definition of the diagonally dominant condition. Okay, now we write the given equation in the simple. First we have to calculate the x from the equation first, and calculate the value y from second, and calculate the value z from third, and then we have to write in the iterative equation. So it is the iterative equation, and here initial approximation is given 0 0 0. So for the we assume it is the equation number first. So for the first iteration we have to put here n equals to 0. Okay, and here we have to put the value of x0 equals to 0, and y not equals to 0, and z not equals to 0. So when you putting the value here n equals to 0, so you will get this one, and in this you will get this one, and in this one. Okay, and you have to put this value x naught y naught z naught equals to 0 0 0 in the equation number second. So you will get the value of x1 y1 z1. So simply I have written here it is the value of x1 y1 z1. Now we have to go for the second iteration. So in the second iteration we have to put n equals to 1 in the iterative equation, so we will get this one. Now here we got the value of x1 y1 z1, so simply we have to put the value of x1 y1 z1 and then simplify, so you will get this value x2 y2 and z2. Now we have to repeat this procedure. So for the third iteration we have to put n equals to 2, and we have to put the previous value in this and simplify, so we will get this value x3 y3 z. So now we have to put n equals to in the iteration equation, so we will get this, and again you have to put the previous value of x, y and z, so you will get this one. And for the fifth iteration you have to put the previous value, means fourth iteration value, so you will get this one. And for the sixth iteration you have to put n equals to 5 in the iterative equation, so you will get this one, and you have to put the previous value equation, this one. So guys, if you look at here, the sixth iteration value and fifth iteration value are nearly equal, or you can say nearly negligible difference between the fifth and sixth is not negligible, so we can say that it is the required solution. Okay guys, so similarly you have to solve the another equation, and thank you for